Hello dear students. So today we will study mass and weight. So in gravitation we've studied about the force of gravitation which acts between two bodies of any kind wherever they are, whether on earth, whether in space, a small body, a big body, whatever. The force of gravitation acts between two bodies, and we know that it is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Coming to mass and weight, we already know what is mass, but we generally confuse these two terms, mass and weight, with each other. Okay, do you know the exact difference between mass and weight? If you say that your weight is 50 kg, okay, generally you say, if I ask you what is your weight and you say my weight is 50 kg, okay. So but we know that the kg is the SI unit of which quantity? Kg is the SI unit of mass, right? 1 kg potatoes, 2 kg mangoes. So when we measure the mass of a body, it is measured in kg. But weight is not measured in kgs. We'll talk about weight a little later. Let's look about mass first. What is mass? You must have studied about mass in chemistry. So we know that mass is the content of matter in a body. How much is the matter? How much is the content matter in a body? That is known as its mass. Okay? Mass is a scalar quantity. Right? Mass is a scalar quantity because we don't say mass is 2 kg in the north direction or mass is 50 kg in the west direction. We don't need mass with its direction. If I say that the mass of a body is this much kg, m kg, that information is enough for me to understand what mass means. Okay, we don't need to specify its direction. That is why it is a scalar quantity. How do we measure mass? You must have seen those balances, right? What are they called? Beam balances, right? A beam balance is used to measure mass. On one side, you must have seen like vegetable and fruits vendors using them very often. So there are specific weights, okay, we call them weights. Like if you have gone to buy 1 kg potato, for example, and you ask the shopkeeper to give you 1 kg potato. So what he does, he keeps 1 kg weight over here, and then he keeps adding potatoes. As soon as he adds 1 kg weight over here, this side of the pan will go down because this is heavy. Then he starts adding potatoes one by one till this becomes balanced. He holds this handle in his hand until both of them become balanced or this rod becomes parallel. He keeps adding so that this is a measure of mass. So here both of them are considered to have same mass, same weight we say, but it is same mass. Okay, so what is used to measure mass? Mass is measured using a beam balance. Okay, mass is constant. That means it doesn't change from place to place. if you have 1 kg potatoes in your home and you take them in your bag and take them to your aunt's home, there also they will measure 1 kg only. Okay, so mass doesn't change from place to place. Okay, then mass of a body, mass cannot be zero. Mass of a body can never be zero. Okay, if a body is there, if it has matter, then it will have mass. Okay, so this is all about mass. SI unit of mass is kg. Okay, and CGS unit of mass is gram, right? 1 kg is 1000 gram. So this is all about mass. Now coming to weight. What is weight? Like I told you that when I ask you what is your weight, you say 50 kg. You are answering me for weight of your body, but you are giving the unit of mass, right? We'll study that, why we do so. Firstly, what is weight? Weight is nothing but the force of gravity acting on a body. So that if there's a body of mass m, okay, then on the surface of the earth, this body is attracted by the force of gravity towards it, okay, and the gravity acts downwards. We say that the force of gravity, force is equals to mass into acceleration. When we talking about the force of gravity, which is the acceleration which acts on every body due to the gravity, that is acceleration due to gravity. So on a body of mass m, acceleration due to gravity when acts, then mg, this product is called weight. Okay, so m is mass, a is acceleration, g is also acceleration. So product of mass into acceleration gives you force. That means weight is a force, right? So mg, force acting downwards, is a force. So if you have a body of mass 1 kg, okay, if you have a body of mass 1 kg, and how much is the acceleration due to gravity? 9.8 meter per second square. Then the force acting on this 1 kg body will be 1 into 9.8, that is 9.8 Newton. This force is denoted by W, weight, because this is how we get the weight of a body. When you stand on a weighing machine, on a weighing scale, when you get on a weighing scale, whatever it shows is the weight of your body, mass multiplied by the acceleration due to gravity. Okay, so weight is, like you know, weight is a force. Since force is a vector quantity, weight is mg. G acts downwards, it is acceleration due to gravity. So acceleration is a vector quantity, acceleration has a direction, that is why weight will also have a direction, right? So weight is a vector quantity, right? Weight is a vector quantity, right? What is the SI unit? The SI unit of weight is a force. So SI unit of force is Newton. So SI unit of weight is also Newton. Okay. CGS unit of weight is dyne. D by N. Dyne. 1 Newton is 10 to the power 5 dyne. Okay. Then mass is a scalar quantity, weight is a vector quantity. How is weight measured? Weight is measured using a spring balance. if you would have been in school, I would have shown you how the spring balance looks like. But this is your homework. You have to Google it and see the picture of a spring balance. How does a spring balance look like and how is it used? That is also included in one of your experiments in ninth. So please search for spring balance in Google and then let me know. Comment after watching this video when you found out about spring balance. So weight is measured using a spring balance. It has a hook like this and it has a scale over here. Okay, a marked scale. It has one more a hanger, a hook like this, to which weight can be attached, mass can be attached. It goes, whenever you attach a mass to it, it will go down because of acceleration due to gravity acting on it, force of gravity acting on it. So when it goes down and settles, this spring balance shows the weight of a body. Okay, so weight is measured using a spring balance. Okay, now weight is not a constant value, since weight is equals to W is equals to mg. So weight depends upon acceleration due to gravity. Mass is constant, but acceleration due to gravity varies from place to place. We've studied the variations in acceleration due to gravity. If you go above the surface of the earth, g reduces. So when g will reduce, automatically weight will reduce. When you go under the surface of the earth, the g reduces. Acceleration due to gravity reduces. When you go at the center of the earth, whatever be the mass of the body, whatever, however huge the body might be, but when you keep that body at the center of the earth, its weight will be zero, because acceleration due to gravity at the center of the earth is zero. Please remember this. Value of acceleration due to gravity at the center of the earth is zero. Okay, so weight changes from place to place. Okay, changes from place to place. Only it will change for changes in acceleration due to gravity. Weight of a body can be zero. Where it will be zero? Wherever g is zero. Places where g is zero, weight will be shown as zero. Okay, so this is the comparative study of mass. So coming to the question where I asked you, why is it that when I ask you your weight, you give me your weight in 50 kg like this. So you are actually specifying your weight, but the unit which you are using is of mass. Okay, so why is it that we can do them interchangeably? So weight, we know, is mass into gravity. Okay, mg. Now g is like at a particular place nearby. For you, you're not going above the surface of the earth, you're not going below the surface of the earth, and you are somewhere on the equator only, so you're not changing place much. Like I'm over here, and if I go to school, so these places are not very far where the value of g will change. Nearby places for like distance of some hundreds of kilometers, the value of g doesn't change. Okay, so g will be constant. That means weight is directly proportional to mass. Directly proportional means if mass is more, weight will be more. If mass is less, weight will be less. See, like if you take a mass of 1 kg, a body having mass 1 kg, what will be its weight? 1 mass 1 into g, 9.8. So that will be 9.8 Newton. If you take a mass of 100 kg, a body whose mass is 100 kg, what will be its weight? 100 into 9.8 mg. So that will be 980 Newton. Can you see the difference? This was lesser mass, its weight is less. This was more mass, its weight is more. So weight is directly proportional to mass, g being constant for nearby places. That is why we like denote them interchangeably, but that is done for like informal purposes. But now you know technically there's a vast difference between mass and weight, and you know what is the difference now between mass and weight, right? So please study mass and weight properly from your textbook. Do all the theory questions related to mass and weight, okay? And study this difference also for mass and weight properly, okay? And one more homework I gave you to study about spring balance on Google, right? So in the next class we will study weight of the body on moon, and we'll see some numericals on that. So this will be like the last topic of this part of the chapter, okay? So please keep revising. If you have any doubts, then please let me know personally. Till then, keep studying. Thank you.